The universe bends. Time slows. Light curves around the edges of stars. And somewhere, in the quiet of a small patent office, a young man sat with a pen and paper, dreaming equations that would rewrite reality itself. His name was Albert Einstein. A boy who couldn't speak until he was 4. A student labeled unremarkable. A dreamer dismissed by teachers and employers alike. Yet he saw what no one else could see. He felt the rhythm of the cosmos in his bones. He turned imagination into mathematics, and mathematics into truth. This is the story of a man who thought in pictures, who rebelled against certainty, and who proved that even the fabric of space and time could be questioned. Tonight, we walk beside him. Through his childhood wonder. Through his lonely brilliance. Through the moments that changed everything. Let his life carry you gently into the night, where curiosity becomes rest, and rest becomes dreams. If these words carry you closer to sleep, let this channel stay by your side too. A gentle tap on subscribe is all it takes to keep these stories with you, night after night. And if this moment feels right, let the like button know. It costs you nothing, but it tells the universe to share this calm with others who need it. Now, settle in. Breathe slow. Albert's story is just beginning. The world into which Albert Einstein was born did not announce his arrival with fanfare. There were no signs in the heavens, no whispers among scholars that something extraordinary had entered the stage of history. It was March 14, 1879, in the modest town of Ulm, nestled along the Danube River in southern Germany. The streets were cobblestone. The air smelled of bread baking and horses passing. Life moved at the pace it had moved for centuries. Hermann Einstein, Albert's father, ran a small electrical business with his brother. Pauline, Albert's mother, played piano and filled their home with melodies that drifted through open windows. They were ordinary people, neither wealthy nor poor, living ordinary lives in an ordinary time. And into this ordinariness came a child who would someday make the extraordinary seem inevitable. But in those first years, Albert was anything but remarkable. In fact, he worried his parents deeply. Most children begin forming words by their second year, stringing sentences together soon after, chattering endlessly as they discover language. Albert did not. He remained silent. He watched. He listened. He absorbed the world around him without offering it a single word in return. His parents exchanged glances across the dinner table, wondering if something was wrong, if their son would ever speak, if he would ever be like the other children. Pauline asked doctors. Hermann grew concerned. Relatives whispered. But Albert simply existed in his own quiet universe, thinking thoughts no one else could hear, seeing patterns no one else had noticed. When he finally did speak, around the age of 4, it was not in the halting, playful way most children learn language. Albert spoke in full sentences, carefully constructed, as if he had been rehearsing them silently for years. He had a peculiar habit. He would repeat sentences to himself under his breath, testing them, refining them, making sure they were right before speaking them aloud. His family called it his echolalia, this strange doubling of words. But it was more than that. It was evidence of a mind that refused to release anything into the world unless it had been examined, questioned, perfected. Even as a small boy, Albert was a thinker first, a speaker second. The world could wait. His thoughts could not. His childhood was neither tragic nor idyllic. It simply was. He played with his younger sister, Maya, who would remain one of the few people who truly understood him throughout his life. He attended Catholic school, despite being Jewish, because it was nearby and practical. He learned the basics, though he rarely enjoyed them. Teachers found him frustrating. He asked too many questions. He challenged explanations. He refused to memorize things he did not understand. Authority annoyed him. Obedience felt unnatural. He was not rebellious in the loud, disruptive way some children are. He was quietly resistant, politely stubborn, intellectually defiant. And that, more than anything, made him difficult. But there were moments. Moments when the boy who seemed so distant, so locked inside himself, suddenly lit up with something close to magic. One of those moments came when Albert was 5 years old. His father, hoping to distract the boy during an illness that kept him confined to bed, brought him a gift. It was small, simple, made of brass and glass. A compass. Hermann placed it in Albert's small hands and watched as the boy stared at the needle. It swung gently, then settled, pointing north. Albert turned the compass. The needle swung again, then returned to the same direction. No matter how he moved it, no matter how he tilted or spun it, the needle always found north. Always. The boy's eyes widened. His breath slowed. Something invisible was controlling that needle. Something he could not see, could not touch, but was undeniably real. A force. A presence. A rule written into the fabric of existence itself. Hermann smiled, thinking it was just a toy. But for Albert, it was a revelation. In that moment, lying in bed with a brass compass in his hands, a question took root in his mind that would never leave him. What else is invisible? What other forces shape the world without being seen? What rules govern everything, hidden just beneath the surface, waiting to be discovered? The compass became a symbol. A reminder that reality is deeper than what the eyes can perceive, that the universe hides its most profound truths in plain sight, and that curiosity is the only key to unlocking them. And so the quiet boy began to wonder. As Albert grew, his silence gave way to something else. Not loudness, but presence. He became a boy who observed more than he participated, who thought more than he spoke, who felt the world in ways that words could not fully capture. His mother noticed it first. Pauline Einstein was a woman of grace and discipline, a lover of art and music, and she believed deeply that culture could shape a soul. She wanted her son to know beauty, to feel it in his bones, to understand that the universe spoke not only in numbers but in melodies. And so she insisted that Albert learn the violin. At first, he resisted. His small hand struggled with the instrument. The bow scraped awkwardly across the strings, producing sounds that were more painful than musical. His teacher was strict, demanding repetition and precision, and Albert hated it. He did not want to memorize scales. He did not want to follow rules. He wanted to understand why music worked, what made certain notes harmonize while others clashed, what invisible structure held a melody together. But understanding was not part of the lesson. Obedience was. And so, for a time, Albert endured the violin without loving it. Then something shifted. He discovered Mozart. Not through his lessons, but on his own, listening to his mother play, hearing the elegance and simplicity of Mozart's compositions. There was a mathematical beauty to it, a structure that felt natural, inevitable, like the needle of a compass finding north. Suddenly, the violin was no longer a chore. It became a language. Albert began to play not because he was told to, but because he wanted to. He played for hours, losing himself in the music, finding in it the same kind of order and mystery he found in the compass, in numbers, in the questions that filled his mind. Music and mathematics were not separate. They were twins. Two ways of describing the same hidden harmony. His father's business struggled. The electrical company was small, competing in a world that was rapidly industrializing, and Hermann Einstein was not a ruthless businessman. He was kind, optimistic, and perhaps too trusting. Contracts fell through. Debts accumulated. The family moved from Ulm to Munich, hoping for better opportunities. Albert adjusted. He always adjusted. But he never quite fit. In Munich, he attended the Luitpold Gymnasium, a prestigious school with high standards and rigid expectations. The teachers valued discipline, memorization, and respect for authority. Albert valued none of those things. He was not a bad student. In fact, in subjects that interested him, mathematics and physics especially, he excelled far beyond his peers. He taught himself calculus at 12, devouring textbooks meant for much older students, working through problems late into the night by candlelight. He saw patterns others missed. He understood concepts others found incomprehensible. But in subjects that bored him, history taught as a list of dates, languages taught as a series of rules, he was indifferent at best, defiant at worst. His teachers grew frustrated. One told him he would never amount to anything. Another suggested he leave, claiming his very presence disrupted the discipline of the classroom. Not because Albert was loud or misbehaved, but because his questions made other students question too. And questions, in that rigid system, were dangerous. Albert felt trapped. School was a prison for his mind, a place where curiosity was punished and conformity rewarded. He spent hours alone, walking through Munich streets, thinking, dreaming, escaping into the private universe inside his head. He read philosophy. He read science. He asked himself questions no one else seemed to care about. What would it be like to ride on a beam of light? If you could move at the speed of light, would time stop? Would the universe look different? These were not idle daydreams. They were thought experiments, the seeds of ideas that would one day become theories, equations, revolutions. But no one knew that yet. To his teachers, Albert Einstein was a problem. To his classmates, he was strange. To himself, he was simply searching. Searching for something true, something solid, something that made sense in a world that often felt arbitrary and cruel. He found pieces of it in mathematics, where 2 + 2 always equaled 4, where logic reigned, where beauty and truth were inseparable. He found pieces of it in music, where harmony was not a rule imposed from above but a natural consequence of vibration and frequency. And he found pieces of it in solitude, where his thoughts could roam freely, unburdened by the expectations of others. His family's financial troubles deepened. Hermann's business failed in Munich. The family made the difficult decision to move again, this time to Italy, to Pavia, near Milan, chasing another chance, another hope. But Albert was expected to stay behind in Munich, to finish his schooling at the gymnasium, to earn his diploma, to follow the path laid out for him. He was 15 years old. And he was miserable. The thought of remaining in that school, in that city, in that suffocating routine, filled him with a quiet desperation. So he made a choice. Without telling his parents, without asking permission, Albert left. He walked away from the gymnasium, secured a doctor's note claiming nervous exhaustion, and traveled alone to Italy to reunite with his family. His parents were shocked. His father was disappointed. But Albert was free. For the first time in his life, he had chosen his own path, rebelled not with violence or anger, but with quiet, determined refusal. He had learned something essential. That rules are not sacred. That authority is not always right. That sometimes, the only way forward is to walk away from what everyone else expects and trust the voice inside that says there must be something more. And there was. There always would be. Italy welcomed Albert like a breath he hadn't known he needed. The air felt different there, warmer, softer, less constricted by the weight of expectation. In Pavia, life moved at a gentler pace. His family had settled into a modest existence, Hermann once again trying to make his electrical business work, Polly maintaining their home with the same quiet grace she always had. Maya, his sister, was delighted to have her brother back. And Albert, for a brief moment, was simply allowed to be. No teachers demanding obedience. No classrooms filled with rules. Just time. Time to think. Time to wander. Time to breathe. He spent his days exploring the Italian countryside, walking through olive groves and along dusty roads, a notebook tucked under his arm. He wrote. He calculated. He dreamed. The landscape seemed to mirror something inside him, open and unstructured, full of possibility. He read voraciously, texts on philosophy and science that he ordered or borrowed, absorbing ideas from Kant, from Spinoza, from Maxwell and Faraday. He was teaching himself, constructing his own education outside the confines of any institution. And in that freedom, his mind expanded in ways it never could have within the rigid walls of the gymnasium. But freedom, he would soon learn, has limits. His father sat him down one evening, the light fading through the window, and spoke with the careful tone of a man delivering difficult news. Albert needed to finish his education. He needed credentials. A diploma. A future. Hermann's business was fragile, and the family could not support Albert indefinitely. The world required qualifications, and without them, even brilliance could go unrecognized, unrewarded, wasted. Albert understood. He did not argue. He knew his father was right, even if the thought of returning to formal schooling filled him with dread. They decided on the Swiss Federal Polytechnic in Zurich, a respected institution known for its focus on science and mathematics. But there was a problem. Albert had no diploma from the gymnasium. To gain admission, he would need to pass an entrance examination. In 1895, at the age of 16, Albert traveled to Zurich and sat for the exam. He excelled in mathematics and physics, solving problems with an ease that astonished the examiners. But in other subjects, languages, biology, literature, he faltered. His knowledge was uneven, brilliant in some areas, deficient in others. The Polytechnic rejected him. It was a blow, but not a fatal one. The director of the Polytechnic, recognizing Albert's extraordinary talent in the sciences, suggested he spend a year at a preparatory school in Aarau, a small Swiss town, to round out his education and try again. Albert agreed. And so he found himself once more in a classroom, once more a student. But Aarau was different. The school was progressive, emphasizing understanding over memorization, encouraging questions rather than punishing them. The teachers respected Albert's intelligence and gave him space to explore. For the first time in his academic life, Albert did not feel suffocated. He thrived. He lived with the family of Jost Winteller, one of his teachers, and they became like a second family to him. The Wintellers were warm, intellectual, full of lively conversation and debate. Albert felt at home among them in a way he rarely had before. He even fell in love, quietly and sweetly, with Marie Winteller, Jost's daughter. She was kind and bright, and for a time, they shared something gentle and uncomplicated. But Albert was not ready for permanence. His heart was restless, his mind too consumed with larger questions to settle into the rhythms of ordinary life. The relationship faded as these young romances often do, leaving behind a tenderness but no bitterness. In 1896, Albert took the entrance exam again. This time, he passed. He enrolled at the Polytechnic in Zurich, officially a student once more, though he would never truly be a conventional one. The Polytechnic offered structure, but Albert resisted it. He attended lectures sporadically, preferring to study on his own, to follow his curiosity wherever it led rather than adhere to a prescribed curriculum. His professors noticed. Some admired his independence. Others found it arrogant. One professor, Heinrich Weber, taught physics with a traditional approach, focusing on classical mechanics and established theories. Albert wanted more. He wanted to learn about Maxwell's equations, about the cutting edge of electromagnetic theory, about the questions that had not yet been answered. Weber refused. The curriculum was the curriculum. Albert stopped attending Weber's lectures. Instead, he spent his time in cafes and his small apartment, reading the latest scientific papers, working through problems on his own, discussing ideas with the few friends who could keep up with him. One of those friends was Marcel Grossmann, a meticulous and disciplined student who took detailed notes in every lecture. While Albert wandered intellectually, Marcel stayed grounded. And when exams approached, Albert borrowed Marcel's notes, crammed, and somehow passed. It was an imperfect system, but it worked. Albert was not interested in being the best student. He was interested in understanding the universe. There was another friend, too. Michel Bessot, an older engineering student, became one of Albert's closest companions. They would walk together for hours, talking about physics, philosophy, life. Bessot was patient, thoughtful, willing to listen to Albert's wildest ideas without judgment. Years later, Albert would say that Bessot was the best sounding board he ever had, a mind that could challenge him without competing with him. These friendships mattered. They kept Albert tethered to the world even as his thoughts drifted into abstractions most people could not comprehend. And then there was Mileva Maric. She was one of the few women in the Polytechnic's physics program, dark-haired and serious, with a quiet intensity that matched Albert's own. She was brilliant, capable of understanding his ideas, of engaging with him on equal intellectual footing. They studied together. They talked for hours. They fell in love, not with grand gestures or romantic declarations, but slowly, deeply, through shared curiosity and mutual respect. Mileva saw Albert not as the difficult student or the dreamer who skipped lectures, but as someone extraordinary, someone worth believing in. And Albert, for his part, found in Mileva a partner, someone who understood the language of his mind. But love, like everything else in Albert's life, would prove complicated. His family disapproved of Mileva. She was older, Serbian, not Jewish, and they worried she would distract Albert from his career, from his future. Pauline Einstein made her feelings clear, and the tension created a rift that would never fully heal. But Albert was stubborn. He did not abandon Mileva, even when doing so might have made his life easier. He held on, determined to forge his own path, to make his own choices, regardless of what others thought he should do. In 1900, Albert graduated from the Polytechnic. Not at the top of his class, but respectably. He had his diploma. He had his freedom. And he had no idea what came next. The universe had given him questions. Now it was time to find the answers. But first, he would need to survive. And survival, he would soon discover, was harder than he ever imagined. Graduation should have been a beginning. Albert Einstein, 21 years old, armed with a diploma from a respected institution, should have stepped smoothly into the academic world that seemed made for minds like his. But the world does not always recognize brilliance when it arrives unpolished, unrefined, unwilling to bow. Albert applied for academic positions. He wrote letters to professors across Europe, offering his services as an assistant, as a researcher, as anything that would allow him to continue thinking, exploring, discovering. The letters went unanswered. Or worse, they were answered with polite rejections, carefully worded dismissals that all carried the same unspoken message. You are not what we need. His former professors at the Polytechnic did not help. Heinrich Weber, the physics professor whose lectures Albert had largely ignored, certainly did not recommend him. Others were lukewarm at best. Albert's independent streak, his refusal to conform, his habit of questioning authority, all the qualities that made him intellectually extraordinary also made him professionally undesirable. Universities wanted researchers who would follow instructions, who would contribute to existing projects, who would fit neatly into established hierarchies. Albert Einstein fit nowhere. And so the doors closed, one after another, leaving him adrift in a world that had no place for him. He took whatever work he could find. Tutoring positions, temporary teaching jobs at small schools, anything to survive. He moved frequently, unable to settle, unable to build any stability. Money was always scarce. His relationship with his family remained strained, especially with his mother, who still disapproved of Mileva and made her feelings known in letters that stung with disappointment. Mileva herself was struggling. She had failed her final exams at the Polytechnic, a devastating blow that ended her academic dreams. She became pregnant. They were unmarried, both barely surviving, and the future looked impossibly uncertain. In 1902, Mileva gave birth to a daughter in secret, far from Zurich, in her family's home in Serbia. They named her Liesel. Almost nothing is known about her. Albert never met her. Whether she was given up for adoption, whether she died in infancy, whether she lived a quiet life under another name, history cannot say for certain. The letters between Albert and Mileva mention her briefly, then she disappears from the record entirely, a ghost in the story of one of history's most famous men. It is one of the saddest mysteries, a reminder that even genius cannot shield a person from heartbreak, from choices made under impossible circumstances, from losses that leave no monuments behind. But life continued, as it always does. Albert kept searching for work, kept applying, kept hoping. And finally, mercifully, a door opened. Marcel Grossman, his friend from the Polytechnic, the one who had shared his meticulous notes, spoke to his father on Albert's behalf. Grossman's father had connections at the Swiss Patent Office in Bern, and they needed an examiner, someone to evaluate patent applications for new inventions and technologies. It was not an academic position. It was not research. It was clerical work, bureaucratic, mundane, far beneath what someone with Albert's abilities should have been doing. But it was stable. It paid. It offered survival. And so Albert accepted. In June of 1902, Albert Einstein became a technical expert third class at the Federal Office for Intellectual Property in Bern. He reviewed patents for electromagnetic devices, evaluated designs for machines and inventions, determined whether they were original, whether they worked, whether they deserved protection. It was tedious work. But it was also oddly fitting. Albert had always been good at seeing through complexity to the essential structure beneath. He could look at a tangled diagram and understand immediately what was clever and what was unnecessary. He could spot flaws, imagine improvements, assess ideas with the same clarity he brought to physics. And the work left his mind free. Unlike an academic position, where he would have been expected to assist with someone else's research, to follow someone else's agenda, the patent office demanded only his attention for a set number of hours. After that, his time was his own. His thoughts were his own. He could spend his evenings and weekends doing what he had always done. Thinking. Questioning. Filling notebooks with ideas that no one had asked for, that no one expected, that no professor would ever grade. In the quiet of his small apartment, in the cafes where he met with friends, in the long walks he took through Bern streets, Albert Einstein continued to wrestle with the universe. He married Mileva in 1903, a small, quiet ceremony with little celebration. His mother did not attend. The marriage was born of love, but also of necessity, of shared struggle, of two people clinging to each other in a world that had not been kind to either of them. They had a son, Hans Albert, born in 1904, and for a time, life took on a domestic rhythm. Albert worked at the patent office. Mileva cared for their son. They lived modestly, always careful with money, always aware of how precarious their situation remained. But in the margins of that ordinary life, something extraordinary was taking shape. Albert had never stopped thinking about light. About time. About motion. The questions that had haunted him since childhood, since the compass, since the thought experiments of his youth, were crystallizing into something more concrete. He had read Maxwell's equations, the mathematical framework that described electricity and magnetism as unified phenomena. He had read about the experiments that tried and failed to detect the ether, the invisible substance that physicists believed filled all space and allowed light to travel. And he had begun to suspect that everyone was wrong. Not slightly wrong. Fundamentally wrong. What if there was no ether? What if light did not need a medium to travel through? What if the speed of light was constant, the same for every observer, no matter how they were moving? And if that was true, what did it mean for time? For space? For everything humanity thought it understood about the universe? These questions consumed him. He discussed them endlessly with Michel Bessot, who worked at the patent office too, who listened patiently as Albert worked through ideas aloud, testing them, refining them, following the logic wherever it led. Bessot did not always understand. But he was there. And sometimes, that was enough. The year 1905 began like any other. Albert went to work. He came home. He played with his son. He lived a quiet, unremarkable life. But inside his mind, a storm was building. And soon, very soon, it would break. Spring arrived in Bern with pale light and cool breezes, but inside Albert Einstein's mind, something blazed. He could not sleep. His thoughts raced, circling problems that had no clear solutions, questions that demanded answers no one had yet found. He was 26 years old, working in a patent office, unknown to the scientific community, carrying ideas so radical that most physicists would have dismissed them as the fantasies of an amateur. But Albert was not fantasizing. He was calculating. He was reasoning. He was seeing connections that had always been there, hidden in plain sight, waiting for someone bold enough to notice them. The first paper came in March. It dealt with something called the photoelectric effect, a puzzling phenomenon where light striking certain metals ejected electrons. Classical physics could not explain it. If light was a wave, as everyone believed, then brighter light should produce more energetic electrons. But experiments showed otherwise. The energy of the electrons depended not on brightness, but on the frequency of the light. Blue light ejected faster electrons than red light, no matter how dim the blue or how bright the red. It made no sense. Unless light was not purely a wave. Unless it also behaved like particles, discrete packets of energy that Albert called quanta. The idea was heretical. Light had been understood as a wave for over a century. But Albert followed the mathematics, and the mathematics did not lie. He submitted the paper to a journal called Annalen der Physik. And he moved on to the next problem. The second paper arrived in May. It explained Brownian motion, the jittery, random movement of tiny particles suspended in liquid, visible under a microscope. Scientists had observed it for decades without understanding why it happened. Albert proposed that the particles were being constantly bombarded by invisible molecules in the liquid, moving randomly, transferring energy through collisions. It was indirect proof that atoms and molecules were real, physical entities, not just theoretical constructs. Some scientists still doubted their existence. Albert's paper made doubt much harder. It was elegant, precise, and it opened a door to understanding matter at scales no one could see. But those two papers, remarkable as they were only the beginning. The storm inside Albert's mind had not yet fully broken. He was working on something else, something bigger, something that would not let him rest. He had been thinking about motion, about observers moving at different speeds, about what they would see, what they would measure, how they would experience time. And he had arrived at a conclusion so strange, so counterintuitive, that even he hesitated before putting it into words. Time was not absolute. Space was not absolute. They were connected, woven together, and they changed depending on how you moved through them. If you traveled fast enough, close to the speed of light, time would slow down for you. Clocks would tick slower. Distances would shrink. Not because of some mechanical failure, but because that was how the universe actually worked. Time and space were not fixed stages on which events unfolded. They were part of the play itself, shifting and bending with motion. The speed of light was the only constant, the one thing every observer agreed upon, no matter how fast they moved. Everything else, even time itself, was relative. It sounded like madness. But the mathematics held. The logic was airtight. And in June of 1905, Albert finished the paper that would introduce special relativity to the world. He called it, On the Electrodynamics of Moving Bodies, a modest title for an immodest idea. He sent it to Annalen der Physik, the same journal that had accepted his earlier work. And then, as if that were not enough, as if rewriting humanity's understanding of time and space were not sufficient, Albert realized he had missed something. There was a consequence buried in the equations, something so profound it deserved its own paper. In September, he wrote a short follow-up. Just 3 pages. It contained the most famous equation in the history of science, though no one knew it yet. E equals mc squared. Energy equals mass times the speed of light squared. Mass and energy were not separate things. They were different forms of the same thing. A tiny amount of mass contained an enormous amount of energy, locked inside, waiting. The equation was simple, almost absurdly so. But it meant that matter itself was a kind of frozen energy, that the universe was far more connected, far more fluid, than anyone had imagined. It meant that the sun's light, the warmth that made life possible, came from mass converting into energy deep in the solar core. It meant that the stars themselves were burning not fuel, but existence. 4 papers. Published in a single year. By a man working in a patent office. A man with no laboratory, no university position, no access to the resources that serious scientists supposedly needed. Albert Einstein had just produced what would later be called his annus mirabilis, his miracle year. And the world barely noticed. The papers were published in a respectable journal, but they were dense, mathematical, written in the dry language of theoretical physics. A few scientists read them. Fewer understood them. And even those who did were not sure what to make of this unknown Swiss patent clerk who claimed to have solved problems that had stumped the greatest minds of the age. Albert returned to his ordinary life. He went to work. He evaluated patents. He came home to Mileva and their son. He played his violin in the evenings, filling their small apartment with music. He did not expect fame. He had never sought it. He had simply followed the questions, let his mind go where it needed to go, trusted that the universe would reveal its secrets if he asked the right way. And it had. Quietly. Privately. Without fanfare. The revolution had begun, but it would take years before the world realized what had happened. But slowly, gradually, the scientific community began to pay attention. Max Planck, one of the leading physicists in Germany, read Albert's paper on relativity and recognized its brilliance. He wrote about it, lectured on it, brought it to the attention of others. Young physicists started citing Einstein's work, testing his predictions, finding that they held. The photoelectric effect paper, the one that suggested light could behave like particles, would eventually help establish quantum theory, though Albert himself would grow uncomfortable with where that theory led. The Brownian motion paper convinced the last skeptics that atoms were real. And special relativity, once people truly understood it, began to reshape physics from the ground up. Albert remained at the patent office. Not because he wanted to, but because academic positions were still elusive, still out of reach. He applied for teaching jobs, hoping to transition into the world he had always belonged to. He was rejected repeatedly. One university told him his publications, though interesting, were too theoretical, too abstract. They wanted someone who could teach practical physics, someone grounded, someone predictable. Albert was none of those things. So he stayed in Bern, kept working, kept thinking. Fame, when it finally came, would find him in the same small office where he had written equations that bent the universe. But fame was still years away. For now, there was only the quiet satisfaction of knowing he had asked the right questions. And found answers that would last forever. The world turned slowly, but it turned. Albert's papers circulated among physicists, passed from hand to hand, discussed in university halls and quiet laboratories across Europe. Some dismissed them. Others were intrigued but cautious, unwilling to abandon centuries of established thought on the word of an unknown patent clerk. But a few, a precious few, recognized what they were reading. Max Planck in Berlin became an advocate. He saw in Albert's work the kind of courage physics needed, a willingness to question everything, to follow logic even when it led somewhere uncomfortable. He invited Albert to conferences, introduced him to other scientists, gave his ideas legitimacy in circles where legitimacy mattered. Albert's life began to change, though not quickly. In 1908, 3 years after his miracle year, he was finally offered an academic position. Not a professorship, not yet, but a lecturer role at the University of Bern. It was part-time, poorly paid, and required him to keep his job at the patent office to survive. His lectures were scheduled early in the morning, before his patent work began, and only a handful of students attended. But it was a start. It was recognition. It was proof that he was more than just a clerk with ideas. He was a teacher, a scholar, someone the academic world could no longer ignore. Then, in 1909, the University of Zurich offered him an associate professorship in theoretical physics. It was a real position, with a real salary, enough to leave the patent office behind. Albert accepted. After 7 years of evaluating other people's inventions, of living in the margins of science, he was finally where he belonged. Mileva was relieved. The move to Zurich brought them closer to familiarity, to the places they had known as students. Their son Hans Albert was growing, and soon they would have another child, Eduard, born in 1910. Life took on a new shape, more secure, more stable, though never entirely peaceful. Because Albert could not stop. The questions that had driven him to relativity, to the photoelectric effect, to Brownian motion, those questions were not finished. Special relativity had solved certain problems, explained how time and space worked for objects moving at constant speeds. But what about acceleration? What about gravity? Newton had described gravity as a force, an invisible pull between masses. But why? What caused it? How did it work across empty space, instantly, without any medium to carry it? Albert sensed there was something deeper, something that special relativity had not touched. And so he began chasing it. It would take him 10 years. 10 years of false starts and dead ends, of calculations that filled hundreds of pages only to collapse into contradictions. 10 years of collaborations and arguments, of ideas tested and discarded, of late nights when he pushed himself to the edge of exhaustion. He moved again, to Prague in 1911, accepting a full professorship at the German university there. He moved again, back to Zurich in 1912, to the Polytechnic where he had once been a student. And then, in 1914, he moved to Berlin, to the Prussian Academy of Sciences, where he was offered a position with no teaching duties, no obligations except to think. It was the dream he had always wanted. Freedom. Resources. Time. But the cost was higher than he expected. Mileva did not want to go to Berlin. She had never been happy in Germany, never felt welcome, and the move felt like exile. Their marriage, already strained by years of struggle, by Albert's consuming obsession with his work, by the emotional distance that grew between them, began to fracture. They fought. Albert retreated into his research, finding in equations the clarity he could not find at home. Mileva took the children and returned to Zurich, leaving Albert alone in Berlin. They would divorce eventually, though it would take years, and the separation would leave wounds that never fully healed. Eduard, their younger son, would struggle with mental illness throughout his life, and Albert's relationship with both his sons would remain distant, marked by absence and regret. Genius came at a cost. And the people closest to him paid it too. But in Berlin, alone in his apartment, surrounded by papers and books, Albert pushed forward. He had help. Marcel Grossmann, his old friend, had taught him the mathematics he needed, a complex branch of geometry that described curved spaces. If space itself could curve, if mass could bend it the way a heavy ball bends a stretched sheet, then gravity was not a force at all. It was geometry. Objects did not fall because they were pulled. They fell because they followed the curves in space created by massive objects like Earth. The sun did not pull the planets toward it. It curved space around itself, and the planets followed those curves, orbiting not because of force, but because curved space gave them no other path. It was breathtaking. It was insane. It was beautiful. Albert worked through the mathematics, testing every possibility, finding equations that described how mass warped space, how space told matter how to move. He made mistakes. He published early versions of the theory that were incomplete, incorrect, and had to retract them, enduring the embarrassment of being wrong in front of the very community that was beginning to take him seriously. But he did not stop. He refined. He corrected. He pushed deeper. And in November of 1915, Albert Einstein completed the field equations of general relativity. 10 equations that described the relationship between matter, energy, space, and time. Equations so elegant, so powerful, that they predicted things no one had ever imagined. Black holes, regions where space curved so violently that not even light could escape. Gravitational waves, ripples in the fabric of space itself, traveling at the speed of light. The expansion of the universe, the possibility that space was not static but growing, stretching, carrying galaxies apart. All of it was hidden in the mathematics, waiting to be discovered. But theories need proof. Equations, no matter how beautiful, are not enough. General relativity made predictions that could be tested. One of them was that light from distant stars would bend as it passed near the sun, following the curve of space the sun created. But starlight near the sun was invisible, washed out by the sun's glare. The only time it could be observed was during a total solar eclipse, when the moon blocked the sun's light and stars became visible near its edge. An eclipse was coming. 1919. And if someone could photograph the stars during that eclipse, measure their positions, compare them to where those stars appeared when the sun was elsewhere in the sky, they could test Einstein's theory. They could prove whether the universe really worked the way he said it did. Albert waited. The war had come, the First World War, and Europe was drowning in blood and mud and senseless death. Science continued, but slowly, hobbled by nationalism and suspicion. Albert opposed the war, signed petitions against it, refused to contribute to weapons development. He was a pacifist in a world gone mad, a voice of reason shouting into a storm. And when the war finally ended, exhausted and broken, the world was ready for something new. Something hopeful. Something that proved humanity could still reach for the stars, even after tearing itself apart. The eclipse came. A British expedition, led by Arthur Eddington, traveled to the island of Principe off the coast of Africa to photograph it. The skies were cloudy. The conditions were poor. But they captured images. They measured. They calculated. And in November of 1919, the results were announced. The starlight had bent. Exactly as Einstein predicted. General relativity was not just mathematics. It was reality. The newspapers exploded. Headlines around the world declared that Newton had been overthrown, that space and time were not what anyone thought, that a new genius had emerged. Albert Einstein's face appeared on front pages from London to New York. He became, almost overnight, the most famous scientist alive. And his life would never be quiet again. Fame is a strange kind of light. It illuminates, but it also distorts. Before November 1919, Albert Einstein was known within scientific circles, respected by physicists who understood the depth of his work. After the eclipse results were announced, after the newspapers proclaimed that Einstein had proven Newton wrong, that the universe was stranger than anyone imagined, Albert became something else entirely. He became a symbol. A celebrity. A face that people recognized even if they could not explain a single equation he had written. And the world, hungry for heroes after the devastation of war, hungry for something beautiful and true, lifted him onto a pedestal he had never asked to stand upon. The headlines were breathless, almost worshipful. Revolution in science, declared the Times of London. New theory of the universe, Newtonian ideas overthrown. Albert's name appeared in bold letters, his photograph printed beside articles that tried, often unsuccessfully, to explain what general relativity actually meant. Journalists who barely understood physics wrote about curved space and bent light as if describing magic. And to most readers, it might as well have been magic. The universe, they were told, was not the solid, predictable place they had always believed it to be. Space could bend. Time could stretch. Reality itself was fluid, shaped by mass and energy in ways that defied common sense. And the man who had discovered this was a rumpled, violin-playing professor with wild hair and kind eyes. He looked like a sage. He spoke in simple, poetic language. He was perfect. Albert was bewildered by it all. He had spent years working in obscurity, content to think and calculate and argue with friends over coffee. Fame felt unnatural, uncomfortable, like a coat that did not fit. He gave interviews because he was asked to. He posed for photographs because cameras followed him wherever he went. He tried to explain relativity in terms ordinary people could grasp, using metaphors and thought experiments, speaking about trains and clocks and observers moving through space. Some understood. Most did not. But it did not matter. They loved him anyway. Not for what he said, but for what he represented. Intelligence. Curiosity. Hope. In a world still recovering from unimaginable loss, Albert Einstein was proof that humanity could still reach beyond itself, still discover truths that transcended borders and politics and hatred. Invitations poured in. Universities wanted him to lecture. Governments wanted him to visit. Scientific societies offered awards, medals, honors. Albert accepted some, declined others, never quite sure what was expected of him. He traveled to Paris, to London, to America. Crowds gathered wherever he went. People cheered. Students pressed forward, hoping to shake his hand, to hear him speak, to be near someone who had touched the infinite. And through it all, Albert remained oddly humble, almost embarrassed by the attention. He knew what he had done was significant, but he also knew it was not finished. General relativity answered some questions, but it raised so many more. And the deeper he looked, the stranger the universe became. His theory predicted things no one had yet observed. Black holes, for instance, regions where gravity was so intense that space curved back on itself, trapping everything inside, even light. The equations clearly allowed for such objects, but they seemed too bizarre to be real. Surely nature would not create something so extreme, so violent. Yet the mathematics insisted. If a star massive enough collapsed under its own gravity, it would not stop. It would compress into a point of infinite density, a singularity, surrounded by a boundary called an event horizon beyond which nothing could return. Albert himself found it unsettling. He published papers arguing that black holes could not actually form, that some unknown mechanism must prevent them. He was wrong. Decades later, astronomers would find them, scattered throughout the cosmos, exactly as his equations predicted. Reality, as always, was stranger than even Einstein imagined. There were other predictions too. Gravitational waves, ripples in spacetime caused by accelerating masses, spreading outward like waves on a pond. If two massive objects, neutron stars or black holes, spiraled toward each other, they would create distortions in the fabric of space itself, stretching and compressing it as the waves passed through. But these waves would be incredibly faint, almost impossible to detect. Albert doubted they would ever be measured. And for nearly a century, he was right. It was not until 2015 that instruments sensitive enough to detect gravitational waves were built, and when they finally observed the signal, the collision of two black holes over 1 billion light-years away, it was exactly as general relativity predicted. The universe had spoken in Einstein's language, 100 years after he wrote the grammar. But perhaps the most profound prediction of all, the one that reshaped cosmology itself, came almost by accident. In 1917, Albert tried to apply his field equations to the universe as a whole. He wanted to describe the large-scale structure of space, to understand whether the universe was finite or infinite, static or changing. But his equations refused to cooperate. They insisted that the universe could not be static. Either it was expanding, growing larger over time, or it was contracting, collapsing inward. Both options seemed absurd. Every astronomer believed the universe was eternal and unchanging, a fixed stage filled with stars and galaxies that had always been there and always would be. To make his equations match that belief, Albert added a term, a constant that represented a kind of repulsive force, pushing space apart just enough to balance gravity's pull and keep everything stable. He called it the cosmological constant. It worked mathematically, but it felt wrong, artificial, like a patch rather than a true solution. And it was wrong. In 1929, an astronomer named Edwin Hubble observed distant galaxies and noticed something extraordinary. They were moving away from Earth. All of them. And the farther away they were, the faster they were receding. The universe was not static. It was expanding, exactly as Einstein's original equations had predicted, before he modified them. Space itself was growing, carrying galaxies apart, stretching like a balloon being inflated. Albert later called the cosmological constant the biggest blunder of his career. But even that blunder would return, decades later, when astronomers discovered that the universe's expansion was accelerating, driven by something they called dark energy. The cosmological constant, it turned out, might not have been a mistake after all. The universe had secrets Einstein glimpsed but could not fully understand. And it still does. Through all of this, through the fame and the discoveries and the relentless attention, Albert tried to hold on to what mattered. His work. His friendships. His music. He played violin almost every day, finding in it a kind of peace that equations could not provide. He wrote letters to friends, to fellow scientists, to strangers who wrote to him with questions or ideas. He was generous with his time, patient with those who did not understand, always willing to explain, to clarify, to share what he knew. He believed science belonged to everyone, that understanding the universe was a human endeavor, not the private domain of experts. And so he made himself available, even when it exhausted him, even when he longed for the quiet obscurity he had once known. But the world would not let him go. It needed him. Not just as a scientist, but as a symbol, a voice, a figure who could speak to something larger than physics. And so Albert found himself pulled into realms far beyond relativity, into politics and morality and the great struggles of his time. And those struggles, he would discover, demanded more from him than any equation ever had. The applause followed him everywhere, but so did the shadows. Fame brought attention, and attention brought scrutiny, expectation, demands that had nothing to do with curved spacetime or the nature of light. Albert Einstein was no longer just a physicist. He was a public figure, a man whose opinions mattered on subjects he had never claimed expertise in. People asked him about politics, about war, about the future of civilization. And Albert, who had spent his life chasing truths in the abstract realm of mathematics, found himself forced to confront truths far messier, far more painful, truths written not in equations but in blood and ash. He had always been a pacifist. Even during the First World War, when nationalism consumed Europe and scientists on all sides contributed to weapons development, Albert refused. He signed petitions calling for peace. He spoke against militarism. He aligned himself with intellectuals who believed that reason and compassion could transcend borders, that humanity's shared curiosity was stronger than the hatreds that tore nations apart. It made him unpopular in some circles, suspect in others. But Albert did not waver. Violence, he believed, solved nothing. It only created more violence, an endless cycle that consumed the best of what humanity could be. His Jewish heritage, which he had largely ignored for most of his life, became unavoidable in the 1920s. Antisemitism was rising across Europe, particularly in Germany, where economic collapse and political instability fed resentment and rage. Einstein, with his fame and his foreign-sounding name and his refusal to conform to nationalist fervor, became a target. Right-wing groups denounced his work as Jewish physics, a conspiracy to undermine German science. They held rallies mocking relativity, calling it a fraud, a distortion of truth designed to weaken the nation. Some even threatened his life. Albert received letters filled with venom, warnings that he was not safe, that his prominence made him vulnerable. He tried not to take them seriously, tried to focus on his work, but the threats were real, and the world was growing darker. He traveled more, partly to escape the hostility in Germany, partly because the world wanted him. He went to Japan, to South America, to Palestine. In 1921, he visited the United States for the first time, arriving in New York Harbor to a reception unlike anything he had ever experienced. Thousands of people lined the docks, cheering, waving, hoping to catch a glimpse of the man whose name had become synonymous with genius. He gave lectures at universities. He met with politicians, with artists, with crowds who treated him like a prophet. America fascinated him, its energy and optimism, its disregard for old hierarchies. But it also unsettled him. The commercialization of everything, the way fame was consumed and discarded, the surface-level enthusiasm that often lacked real understanding. He admired the country, but he never fully trusted it. In 1922, Albert was awarded the Nobel Prize in Physics. Not for relativity, which was still controversial, still too radical for the conservative Nobel Committee to embrace fully. Instead, they honored him for his work on the photoelectric effect, the paper from his miracle year that had introduced the idea of light quanta. It was a safe choice, a way to recognize Einstein's brilliance without endorsing the theory that had made him famous. Albert did not attend the ceremony. He was traveling, and besides, the prize felt less significant than the work itself. What mattered was not the recognition, but the questions, the endless pursuit of understanding. The Nobel Prize was a footnote. The universe was the story. But even the universe could not hold his full attention anymore. Europe was unraveling. In Germany, the Weimar Republic struggled under the weight of hyperinflation and political chaos. Extremist movements grew louder, more violent. Adolf Hitler's Nazi Party, once a fringe group, began attracting followers, spreading a message of racial purity and national rebirth that blamed Germany's problems on Jews, communists, intellectuals, anyone who did not fit their vision. Albert watched with growing alarm. He spoke out, using his platform to warn against the dangers of fascism, to advocate for democracy, for tolerance, for the values he believed were worth defending. But warnings are easy to ignore when people are desperate, angry, looking for someone to blame. By the early 1930s, Albert knew he could not stay in Germany. The Nazis were gaining power, and their rhetoric grew more explicit, more dangerous. Jewish professors were being dismissed from universities. Books were being burned. Violence was becoming normalized. Albert's name appeared on lists of enemies, intellectuals to be silenced. His apartment was searched. His bank accounts were scrutinized. Friends urged him to leave, to find safety before it was too late. And in December of 1932, Albert Einstein left Germany for a lecture tour in the United States. He would never return. When Hitler became chancellor in January 1933, Albert was in California. He watched from across an ocean as his homeland transformed into something monstrous, as laws stripped Jews of their rights, as violence became policy, as the country that had produced Goethe and Beethoven and Kant embraced madness. Albert renounced his German citizenship. He resigned from the Prussian Academy of Sciences. He became, once again, a refugee, a man without a country, though this time the world knew his name. Princeton University offered him a position at the newly established Institute for Advanced Study, a place where he could work without teaching obligations, surrounded by other brilliant minds, safe from the horrors unfolding in Europe. He accepted. And so Albert Einstein settled in Princeton, New Jersey, a small college town that would be his home for the rest of his life. He lived simply. A modest house on Mercer Street, walking distance from the institute. No car, no chauffeur, no trappings of wealth or fame. He walked to work each day, dressed in rumpled sweaters and worn shoes, greeting neighbors, stopping to chat with children, looking for all the world like an absent-minded professor from a storybook. And in many ways, that is what he had become. Not the symbol the world had made him, not the icon on magazine covers, but a man trying to live a quiet life, trying to think, trying to make sense of a universe that was both beautiful and incomprehensible. But the world would not let him rest. News from Europe grew worse. Jews were being rounded up, sent to camps, murdered in numbers too staggering to comprehend. Albert's friends, his colleagues, people he had known and worked with, disappeared into the machinery of genocide. He felt helpless, guilty for his safety while others suffered, desperate to do something, anything, to stop the horror. He wrote letters, gave speeches, raised money for refugees. He used his fame to draw attention to the atrocities, to beg the world to act. But the world moved slowly, reluctantly, and by the time it finally responded, millions were already dead. And then, in 1939, a letter arrived. Written by fellow physicist Leo Szilard, signed by Einstein, addressed to President Franklin Roosevelt. It warned that Nazi Germany might be developing an atomic bomb, a weapon of unimaginable destructive power, based on the principles of nuclear fission. The letter urged the United States to begin its own research, to ensure that Hitler did not gain such a weapon first. Albert signed it, knowing the weight of what he was doing, knowing that his name would lend urgency to the message. The letter helped launch the Manhattan Project, the secret effort to build the atomic bomb. Albert himself was not involved in the project. His pacifist views and his foreign birth made him a security risk. But his equation, E equals mc squared, the one he had written in 1905, was at the heart of it. Mass into energy. Matter into devastation. The bomb was built. And in August of 1945, it was used. Hiroshima. Nagasaki. Two cities erased in flashes of light and heat. Tens of thousands dead in an instant. Tens of thousands more dying slowly from radiation. The war ended. Japan surrendered. And Albert Einstein, the man whose theories had unlocked the power of the atom, was left with a burden he would carry for the rest of his life. He had not built the bomb. He had not wanted it used. But his name, his work, was tangled up in it forever. And the question that haunted him, the one he could never fully answer, was whether knowledge itself carried guilt, whether understanding the universe made him responsible for how that understanding was used. He spent the rest of his years advocating for nuclear disarmament, for international control of atomic weapons, for a world where science served peace rather than destruction. But the bombs were built. The arms race began. And the universe, indifferent as always, continued expanding, carrying galaxies into the dark, while on one small planet, humanity struggled with the knowledge it had gained. Albert had bent the universe with his mind. But he could not bend the human heart. And that, perhaps, was the hardest truth of all. The years in Princeton unfolded quietly, though the world outside remained loud and turbulent. Albert Einstein had become an institution, a living monument to human intellect, yet inside his modest home on Mercer Street, he was simply a man growing older, wrestling with questions that had no clear answers. His hair, already wild in his youth, turned white and seemed to defy gravity itself, giving him the appearance of a kindly wizard from some ancient tale. Children in the neighborhood loved him. He would stop on his walks to help them with their homework, to explain why the sky was blue or how a bicycle stayed upright. He was patient, gentle, never condescending, always treating their curiosity as sacred. But beneath that gentle exterior, a battle raged. Physics was changing, moving in directions that disturbed him deeply. The quantum mechanics that had begun with his own work on the photoelectric effect had evolved into something strange, something that violated his deepest intuitions about how reality should behave. According to quantum theory, particles did not have definite positions or velocities until they were measured. They existed in a state of probability, a blur of potential outcomes that only collapsed into certainty when observed. Even more troubling, particles could be entangled, connected in ways that allowed them to affect each other instantaneously across vast distances, as if space itself meant nothing. Einstein called it spooky action at a distance, and he hated it. He could not accept that the universe was fundamentally random, that at its deepest level, reality was governed by chance rather than law. God does not play dice with the universe, he famously declared, pushing back against the probabilistic interpretation that most physicists had embraced. He spent years constructing thought experiments designed to expose flaws in quantum mechanics, to prove that it was incomplete, that there must be hidden variables, deeper laws that determined what appeared to be random. His most famous challenge came in 1935, a paper written with two colleagues, Boris Podolsky and Nathan Rosen, now known as the EPR paradox. It argued that quantum mechanics led to absurd conclusions, that it allowed for effects without causes, connections without explanations. Surely, Einstein insisted, there was something more. But the young physicists, Niels Bohr and Werner Heisenberg and their followers, stood firm. Quantum mechanics worked. Its predictions were confirmed by every experiment. The universe, they said, simply was not what Einstein wanted it to be. Reality at the quantum level was probabilistic, uncertain, fundamentally weird. And while Einstein's objections were brilliant, they changed nothing. The dice kept rolling, and the universe kept revealing itself as stranger than any classical picture could capture. Albert found himself in the uncomfortable position of being proven right about so much, yet unable to convince anyone on this. He was the elder statesman, respected but increasingly isolated, arguing against a tide that would not turn. He did not give up. Even as his contemporaries moved on, as quantum mechanics became the foundation of modern physics, Albert continued searching for what he called a unified field theory, a single framework that could unite gravity and electromagnetism, that could explain everything from the largest galaxies to the smallest particles. He filled notebooks with calculations, trying different approaches, different mathematical structures, hoping to find the elegant equation that would tie it all together. He published papers proposing various solutions, but none gained traction. The problem was too hard, the tools insufficient, or perhaps the universe simply did not work the way he hoped. But he could not stop trying. It was who he was. A man who asked questions and refused to settle for incomplete answers, even when completeness seemed forever out of reach. His personal life remained complicated, marked by both warmth and distance. He remarried in 1919, to his cousin Elsa, a practical woman who managed his life and protected him from the chaos that fame brought. She died in 1936, and Albert grieved quietly, as he did most things, keeping his pain private. His relationship with his sons remained strained. Hans Albert became an engineer, living in California, and they maintained cordial contact, though the closeness Albert might have wanted never materialized. Edouard, his younger son, suffered from schizophrenia and spent much of his adult life in psychiatric institutions in Switzerland. Albert supported him financially but could not be there, separated by an ocean and by his own inability to navigate the emotional complexity his son's illness demanded. He carried guilt about it, about the choices he had made, about the ways his relentless focus on physics had cost him connection with the people he loved. But there were friendships, deep and enduring. Kurt Gödel, the brilliant logician who had proven that mathematics itself was incomplete, walked with Albert almost daily through Princeton streets. They made an odd pair, Gödel anxious and reclusive, Einstein warm and approachable, but they understood each other. They talked about time, about logic, about the nature of existence. Gödel even found solutions to Einstein's field equations that allowed for time travel, closed time-like curves where you could journey into your own past. Albert was both fascinated and disturbed by the idea. The mathematics allowed it, but surely nature would find a way to forbid it. The universe, he believed, must have some sanity, some order that prevented paradox. But Gödel's work suggested otherwise. Reality, it seemed, had no obligation to make sense. Albert remained politically active, using his voice on behalf of causes he believed in. He spoke out for civil rights, supporting the struggle of Black Americans against segregation and discrimination. He joined the NAACP, corresponded with leaders like W.E.B. Du Bois, refused to stay silent in the face of injustice. When the House Un-American Activities Committee began its witch hunts during the early Cold War, investigating artists and intellectuals for supposed communist sympathies, Albert denounced it as a betrayal of American values. He believed in freedom, in the right to think and speak without fear, and he was willing to defend those principles even when it made him unpopular, even when FBI Director J. Edgar Hoover opened a file on him, monitoring his activities, suspecting him of subversion. Albert did not care. He had fled one authoritarian regime. He would not be silenced by another. He advocated for world government, for international cooperation, for structures that could prevent war and manage the nuclear threat that now hung over humanity. He believed that nationalism, the tribalism that divided people into competing nations, was one of humanity's greatest failings, a relic of a more primitive time that had become dangerously obsolete in an age of atomic weapons. Only by transcending borders, by recognizing our shared humanity, could we survive. It was an idealistic vision, perhaps impossibly so, but Albert never stopped believing it was necessary. He wrote articles, gave speeches, lent his name to organizations working toward peace. And though the world did not transform as he hoped, though the Cold War deepened and the arms race accelerated, he continued trying, right up until the end. His health began to fail. An aortic aneurysm, detected in 1948, was a ticking clock inside his chest. Doctors could do little. Surgery was risky, and at his age, perhaps not worth attempting. Albert accepted the diagnosis with characteristic equanimity. He had lived a long life, seen things few humans ever see, contributed something meaningful to humanity's understanding of existence. When death came, it would come. There was no point in fear. He continued working, continued thinking, continued filling notebooks with equations. The unified theory still eluded him, and he knew, deep down, that it probably always would. But the search itself mattered. The refusal to give up mattered. That was the lesson. Not that we can solve every mystery, but that we must keep trying. On April 18, 1955, at the age of 76, Albert Einstein died in his sleep at Princeton Hospital. An aneurysm had ruptured during the night. He was alone, as he often was, and perhaps as he preferred to be. On his bedside table lay a notebook, open to pages filled with equations, symbols representing the forces of nature, the last attempts of a mind that never stopped reaching. The hospital called his family. The world was informed. And within hours, newspapers across the globe carried the news. The greatest mind of the 20th century was gone. But his legacy was not. It lived in every equation that described the cosmos, in every measurement of gravitational waves, in every observation of black holes and expanding space. It lived in the students he inspired, the scientists who followed paths he had opened. It lived in the principle that curiosity is sacred, that questioning authority is necessary, that imagination is more important than knowledge because knowledge is limited while imagination embraces the entire universe. Albert Einstein had shown humanity how to think bigger, how to see farther, how to ask questions that seemed impossible and find answers written in the language of mathematics and light. Tonight, as his story reaches this quiet ending, we remember not just the genius, but the man. Flawed, stubborn, endlessly curious, deeply human. A boy who stared at a compass and wondered. A student who walked away from what did not serve him. A patent clerk who rewrote reality. A refugee who never stopped fighting for a better world. The stars still shine. Space still curves. Time still flows in ways Newton never imagined. And somewhere in the equations, in the beauty of a universe that reveals itself to those brave enough to look, Albert Einstein's spirit remains, asking one more question, chasing one more answer, reminding us that wonder is the beginning of all wisdom. Rest now. The universe is vast and strange and beautiful. And tomorrow, when you wake, it will still be waiting, full of mysteries, inviting you to dream. There is a loneliness that comes with being understood by few and recognized by many. Albert Einstein lived in that strange space, where millions knew his face but only a handful could follow his thoughts. Fame had made him visible, but it had not made him less alone. In Princeton, he walked the same streets each day, nodded to the same neighbors, sat in the same chair at the Institute for Advanced Study. Routine gave him structure, a framework within which his restless mind could wander freely. But beneath the surface, beneath the public image of the kindly genius with the unruly hair, there was a man carrying weights that equations could not lift. His first marriage had ended in pain. Mileva had returned to Zurich with their sons years earlier, and the divorce, finalized in 1919, left scars that never fully healed. Albert had promised her the money from his Nobel Prize, a guarantee made before he even won it, a way of providing for her and the boys when he could not be present himself. When the prize came in 1922, he kept his word, though the gesture felt hollow, a financial transaction standing in for the emotional support he had failed to give. Hans Albert, his older son, grew up resenting his father's absence, the way physics always came first, the way fame consumed the man who should have been simply a father. They maintained contact, exchanged letters, but the warmth was forced, the connection strained by years of distance. Edouard, his younger son, struggled more profoundly. As a boy, he had been bright, sensitive, drawn to music and literature. But in his late teens, something shifted. He began experiencing episodes of paranoia and delusion, hearing voices, losing touch with reality. The doctors diagnosed schizophrenia, a condition that in the 1930s had no effective treatment, no cure, only confinement and waiting. Edouard spent years in and out of psychiatric hospitals, his brilliant potential dissolving into illness. Albert supported him financially, paid for his care, but could not visit, separated by the ocean and by his own helplessness. He wrote letters, filled with love and regret, but letters could not bridge the chasm that mental illness creates. And so Edouard lived out his days in institutions, and Albert carried the guilt of a father who had given the world his genius but could not save his own son. Elsa, his second wife, had been a stabilizing presence, managing his correspondence, organizing his life, shielding him from the endless demands that fame brought. She was practical where he was abstract, grounded where he was floating. But she died in 1936, and her absence left a void. Albert mourned, though he did so privately, never one to display emotion publicly. After her death, his household was managed by his stepdaughter Margot and his secretary Helen Ducas, two women who devoted themselves to protecting his time, his peace, his ability to work. They understood that his mind was his sanctuary, and they guarded it fiercely. But fame is a relentless thing. It does not respect boundaries or privacy or the simple desire to be left alone. Letters arrived by the hundreds, from scientists seeking collaboration, from students asking for advice, from strangers wanting autographs or asking absurd questions or sharing theories that made no sense. Albert tried to respond when he could, believing that every person deserved respect, that curiosity should be encouraged even when it was misguided. But the volume was overwhelming. He could not possibly answer everyone, and the guilt of that weighed on him too. People wanted pieces of him, and there were only so many pieces to give. The world also wanted him to speak, to lend his voice to causes, to take positions on issues far removed from physics. And Albert, who had never been able to remain silent in the face of injustice, found himself pulled into battles he had not chosen. The rise of fascism in Europe had driven him from his homeland, but the threat did not end with his escape. Antisemitism was not confined to Germany. It existed in America too, more subtle perhaps, but present. Albert experienced it in small ways, the suspicion, the otherness, the sense that he would always be a foreigner no matter how long he lived in Princeton. He did not let it silence him. Instead, he spoke more loudly, advocating for Jewish refugees, for the establishment of a Jewish homeland, for the right of persecuted people to find safety and dignity. But his relationship with Zionism was complicated. He supported the idea of a Jewish state, a place where Jews could live without fear, without persecution. He traveled to Palestine in the 1920s, was moved by the energy and hope he found there, by the sight of people building something new in an ancient land. But he was also troubled by the nationalism he saw, by the way some Zionists spoke of Arabs as obstacles rather than neighbors, by the potential for the same tribalism that had caused so much suffering in Europe to take root in the Middle East. Albert believed in coexistence, in shared governance, in solutions that honored the dignity of all people. When Israel was established in 1948, he celebrated, but he also warned. A nation built on exclusion, on the denial of others' rights, would not achieve lasting peace. It was a message few wanted to hear, and it earned him criticism from all sides. But Albert was used to being out of step with popular opinion. Truth, he believed, was not determined by consensus. The atomic bomb haunted him. Not in the way guilt haunts a criminal, for he had not built it, had not dropped it, had only signed a letter warning that it might be built by others. But the knowledge that his work, his insights into the nature of mass and energy, had enabled such destruction left a mark. He spoke against nuclear weapons constantly, urging international control, advocating for disarmament, warning that humanity now possessed the power to destroy itself and that only wisdom, compassion, and cooperation could prevent catastrophe. He joined organizations dedicated to peace, wrote articles, gave interviews, used every platform available to plead for sanity in an increasingly insane world. But the Cold War had begun, and sanity was in short supply. The United States and the Soviet Union, allies during the war against fascism, now faced each other with hostility and suspicion. Both sides built more bombs, bigger bombs, hydrogen bombs that made the weapons dropped on Japan seem almost quaint by comparison. The arms race accelerated, driven by fear and pride and the logic of mutually assured destruction. Albert watched it unfold with a sense of despair he rarely allowed himself to feel. Humanity had unlocked the secrets of the atom, had glimpsed the fundamental workings of the universe, and it was using that knowledge to build instruments of annihilation. What was the point of understanding reality if it only enabled us to destroy ourselves? He was asked once what weapons would be used in World War III. His answer was simple and chilling. I do not know with what weapons World War III will be fought, but World War IV will be fought with sticks and stones. It was not a joke. It was a prediction, a warning, a recognition that the path humanity was on led toward oblivion. And yet, people kept walking that path, kept building bombs, kept preparing for a war that would end everything. Albert felt powerless, a voice in the wilderness, respected but ignored, famous but ineffective. The FBI did not trust him. J. Edgar Hoover, paranoid and power-hungry, had opened a file on Einstein in the 1930s, convinced that the physicist's pacifism and internationalism were evidence of communist sympathies. The file grew over the years, filled with surveillance reports, intercepted letters, notes from informants who attended his lectures and reported on what he said. Hoover wanted Einstein deported, labeled a security risk, silenced. But Einstein was too famous, too beloved, and the evidence of wrongdoing was non-existent. So Hoover watched and waited, and Albert, aware of the surveillance, refused to be intimidated. He continued speaking his mind, continued advocating for peace, continued believing that principles mattered more than safety. The weight of the world pressed down, but Albert did not break. He bent, perhaps, under the accumulated sorrows and disappointments, the recognition that his voice, for all its reach, could not prevent the darkness he saw gathering. But he did not surrender to despair. He kept working. He kept thinking. He kept believing that somewhere in the mathematics, in the elegant language of physics, there were answers that mattered, truths that transcended the madness of human affairs. The universe did not care about politics or war or the fears that drove nations apart. It simply was, vast and indifferent and beautiful, and understanding it remained the most meaningful thing he knew how to do. His search for a unified field theory continued, though he knew most physicists considered it a lost cause. They had moved on, embraced quantum mechanics fully, focused on the subatomic realm where particles danced in probabilistic clouds. Albert was chasing a different dream, a classical dream, the belief that beneath the randomness there must be order, that gravity and electromagnetism were not separate forces but expressions of some deeper geometry. He tried approach after approach, testing different mathematical structures, publishing papers that generated little interest. His methods were outdated, his colleagues said. The future was quantum, not classical. But Albert persisted, not because he was stubborn, though he was, but because he could not abandon the vision that had driven him since his youth. The universe was comprehensible. It had to be. And if no one else believed that anymore, he would believe it alone. There were moments of connection, brief respites from the loneliness. His daily walks with Kurt Gödel became ritual, two minds that understood the limits of understanding, that had both proven in different ways that certainty was impossible, that even mathematics contained statements that could neither be proven nor disproven. They walked slowly, Gödel nervous and frail, Albert increasingly stooped with age, talking about time and logic and existence. They did not solve anything on those walks. But they kept each other company, two refugees from a Europe that no longer existed, two thinkers who had glimpsed infinity and been changed by it. There were students too, younger physicists who sought him out, not for his current work, which few understood or valued, but for the wisdom that comes from having lived through revolutions, from having been both celebrated and dismissed, from knowing what it means to be right when everyone else is wrong. Albert was generous with his time, patient with questions, willing to explain concepts to anyone genuinely curious. He never talked down to people, never used his fame as a weapon or his intelligence as a barrier. He remembered what it was like to be young and uncertain, to have ideas that no one took seriously, to feel invisible in a world that valued conformity over creativity. And so he made himself available, a bridge between generations, a reminder that science was not a hierarchy but a conversation that spans centuries. He also wrote, not just papers but essays and letters, reflections on science and society, on the responsibilities of intellectuals, on the relationship between knowledge and morality. He believed scientists had a duty to speak beyond their disciplines, to engage with the ethical implications of their work, to use their understanding of how the universe operates to inform how humanity should operate. Science without conscience was dangerous. Intelligence without compassion was meaningless. And so he wrote about democracy, about freedom, about the need for education that taught people to think rather than simply obey. He wrote about the dangers of militarism, the foolishness of nationalism, the importance of protecting individual rights even when collective fear demanded conformity. In 1952, something unexpected happened. Israel's first president, Chaim Weizmann, died, and the Israeli government offered Albert Einstein the presidency. It was largely a ceremonial role, a symbol more than a position of real power, but the offer was sincere. They wanted the world's most famous Jew to lead the world's newest Jewish state. Albert was deeply moved by the gesture, by the recognition and respect it represented. But he declined. He was not a politician, he explained. He lacked the temperament for diplomacy, the ability to navigate competing interests and find compromises. He was a scientist, a thinker, someone who dealt in truths that did not require negotiation. To place him in a political role would serve neither him nor Israel. It was a gracious refusal, honest and self-aware, and it revealed something essential about Albert. He knew his limits. He understood what he was good at and what he was not. Fame had not made him arrogant. If anything, it had made him more humble. The 1950s brought a different kind of darkness. McCarthyism swept through America, a paranoid hunt for communists and subversives that destroyed careers and lives. Intellectuals, artists, scientists, anyone who had ever expressed sympathy for socialist ideas or questioned American policy, found themselves targeted. Albert watched colleagues called before congressional committees, forced to name names, to betray friends in order to save themselves. He was disgusted. It reminded him too much of what he had fled in Germany, the same mentality, the same willingness to sacrifice truth and justice for the illusion of security. He spoke out, urging people to refuse to cooperate, to invoke their constitutional rights, to stand firm even when threatened. The fear of communism has led this country to abandon its principles, he wrote. We are becoming the thing we claim to fight. His words carried weight, but they also carried risk. The FBI's surveillance intensified. Hoover wanted evidence, anything that could be used to discredit Einstein, to paint him as a traitor or a fool. But there was nothing. Albert had never joined the Communist Party, had never advocated for overthrowing the government, had simply insisted on the right to think freely and speak honestly. And so Hoover's file grew thicker with nothing of substance, a monument to paranoia and wasted effort. Albert knew he was being watched, but he refused to change his behavior. If they want to waste their time following an old man who talks about peace, he said, let them. His health deteriorated slowly. The aneurysm in his aorta was always there, a balloon of weakened blood vessel wall that could rupture at any moment. Doctors monitored it, but there was little they could do. Surgery in the 1950s was crude, risky, especially for a man in his 70s. Albert accepted the situation with his characteristic calm. Death was not something to fear. It was simply the end of a process, the cessation of consciousness, the return to the non-existence from which he had briefly emerged. He had lived fully, thought deeply, loved imperfectly, contributed something meaningful. What more could anyone ask? He continued working until the very end. Even when his body weakened, even when walking became difficult and pain was constant, his mind remained sharp, still chasing the unified theory, still filling notebooks with equations. He knew he would not finish. The problem was too vast, perhaps unsolvable with the tools available, perhaps requiring insights that would not come for decades or centuries. But the work itself was the point. The refusal to give up. The insistence that questions mattered even when answers were elusive. That was the legacy he wanted to leave, not just the theories he had completed, but the spirit of inquiry he embodied, the courage to keep asking even when the universe remained silent. In April of 1955, the aneurysm began to leak. Albert felt the pain, knew what it meant. He was hospitalized, but he refused surgery. "I have done my share," he told the doctors. "It is time to go." He wanted to die with dignity, without intervention, without machines prolonging what was already finished. They brought him paper and a pen. He wanted to keep working, to use whatever time remained. And so, in his hospital bed, Albert Einstein continued writing equations, exploring the geometry of spacetime, reaching for the unity that had always eluded him. On the night of April 17, the aneurysm ruptured. He was alone, as he often preferred to be, and he died in his sleep, peacefully, without drama. The notebook on his bedside table remained open, the equations unfinished, a final thought interrupted mid-calculation. The hospital called his family. The news spread. And around the world, people paused, recognizing that something had ended, that a light had gone out, that the man who had taught humanity to see the universe differently would see no more. But the universe he revealed continues. And the questions he asked still echo, inviting each new generation to wonder, to imagine, to reach beyond what is known toward what might be understood. Albert Einstein was not perfect. He was not a saint. He was a man, flawed and human, who happened to possess a mind capable of glimpsing truths hidden from ordinary sight. And in that glimpsing, in that relentless pursuit of understanding, he showed us what we might become if we dare to ask, if we refuse to accept easy answers, if we keep looking up at the stars and wondering what they have to teach us. Death is not an ending for those whose work transcends their time. Albert Einstein's body was gone, cremated according to his wishes, his ashes scattered in an undisclosed location so that no grave would become a shrine, no monument would replace the ideas he left behind. But his presence remained, woven into the fabric of physics, embedded in the way humanity understood reality. The equations endured. The questions persisted. And the world, which had celebrated him and misunderstood him in equal measure, began the long process of reckoning with what he had truly given. In the days after his death, newspapers filled their pages with tributes and retrospectives, attempting to capture the essence of a man who had been both icon and enigma. They printed the famous photograph, the one where he stuck out his tongue, playful and irreverent, a reminder that genius did not require solemnity. They recounted his greatest achievements, relativity and the photoelectric effect, E equals mc squared. They called him the greatest scientist since Newton, perhaps the greatest mind humanity had ever produced. But most of the tributes missed something essential. They celebrated what he had discovered, but they did not fully grasp what he had taught. That curiosity is sacred. That authority should be questioned. That imagination matters more than knowledge because imagination opens doors that knowledge cannot even see. The scientific community mourned in its own way, recognizing the loss of a giant, but also acknowledging that Einstein's later work, his decades-long quest for a unified field theory, had led nowhere. He had been chasing a dream that physics had moved past, trying to force the universe into a classical framework when quantum mechanics had already proven that reality operated on different principles. His stubbornness, which had served him so well in his youth, had become an obstacle in his later years. Or so many believed. But history has a way of revealing patterns that only become clear with distance, and the story of Albert Einstein's final quest is more complicated than simple failure. He had been right about so many things that seemed impossible. Time dilation. Length contraction. The bending of light. The equivalence of mass and energy. Black holes. Gravitational waves. The expansion of the universe. Every prediction, no matter how strange, had eventually been confirmed. And yet, in his battle against quantum mechanics, in his insistence that God does not play dice, he had been wrong. Or had he? Quantum mechanics worked, there was no denying that. Its predictions were accurate to astonishing precision. But it was also incomplete in ways that troubled many physicists, not just Einstein. It could predict probabilities but not causes. It described what happened but not why. And the question of whether there was something deeper, some hidden order beneath the randomness, remained open. Still remains open, even now, decades after Einstein's death. His dream of a unified theory, dismissed by his contemporaries, would inspire future generations. In the 1960s and 70s, physicists began developing theories that attempted to unify the fundamental forces, not in the way Einstein had imagined, but with similar goals. String theory, proposed in the late 20th century, suggested that particles were not points but tiny vibrating strings, and that the universe had more dimensions than the four we experience. It was wildly speculative, mathematically complex, and impossible to test with current technology. But it was an attempt to do what Einstein had tried to do, to find a single framework that explained everything. Whether it would succeed remained to be seen. But the impulse, the belief that such unity existed and could be found, came directly from Einstein's example. His skepticism about quantum mechanics also proved prescient in unexpected ways. The EPR paradox, the thought experiment he had constructed to show quantum mechanics was incomplete, became the foundation for quantum information theory. The spooky action at a distance he had mocked was real, and it became the basis for quantum entanglement, a phenomenon now being explored for applications in quantum computing and cryptography. Einstein had meant to disprove quantum mechanics. Instead, he had identified one of its most profound features. Even in being wrong, he had been useful. Even in arguing against the tide, he had advanced understanding. His personal papers, thousands upon thousands of pages of correspondence, notebooks, drafts, and calculations, were preserved and eventually made available to scholars. They revealed a man more complex than the public image, more human than the icon. Letters to friends showed his humor, his warmth, his capacity for doubt. Letters to Mileva showed the complications of love, the ways two people can care deeply for each other and still cause each other pain. Letters to his sons showed a father trying, imperfectly, to maintain connection across distances both geographical and emotional. The notebooks showed a mind that never stopped working, never stopped questioning, filling page after page with ideas, some brilliant, some dead ends, all evidence of a restless intellect that could not be contained. His brain, controversially, had been removed during the autopsy, taken by the pathologist without permission, preserved, studied, sliced into sections and distributed to researchers hoping to find some physical explanation for his genius. They found nothing conclusive. His brain was not dramatically larger or structured differently in obvious ways. Genius, it seemed, could not be located in tissue and neurons, could not be weighed or measured or replicated. It remained a mystery, an emergence of complexity that science could not yet explain. The brain itself became a kind of relic, fragments stored in jars, a grotesque attempt to capture something that had never been physical to begin with. Albert would have found it absurd, this dissection of the organ that had housed his thoughts, as if understanding could be found in anatomy rather than ideas. His legacy in physics was secure, unchallengeable. Relativity had become the foundation of cosmology, the framework through which scientists understood the universe at its largest scales. Every observation of distant galaxies, every measurement of cosmic expansion, every prediction about the fate of the universe, rested on equations Albert had written. Gravitational wave detectors, built a century after he first predicted their existence, were now observing collisions between black holes billions of light-years away, seeing the universe in a completely new way, hearing the whispers of spacetime itself. The GPS satellites that orbit Earth, providing navigation to billions of people, had to account for relativistic time dilation or they would quickly become inaccurate. Albert's theories were not abstract philosophy. They were woven into the technology of daily life, invisible but essential. But his legacy extended beyond equations. He had shown that science was not the domain of the privileged or the credentialed, that breakthroughs could come from patent clerks and outsiders, that the only requirement for doing great work was curiosity and courage. He had demonstrated that questioning authority was not disrespect but necessity, that progress required challenging what everyone believed to be true. He had lived as a refugee, an outsider, someone who never fully belonged anywhere, and he had used that position to speak uncomfortable truths, to advocate for justice and peace even when it made him unpopular. He had been both famous and alone, celebrated and misunderstood, a symbol of intellect and a reminder of humanity's capacity for wonder. The world that continued without him was shaped by his presence in ways both visible and hidden. Students in classrooms around the globe learned his name before they learned his theories, absorbed the image of wild white hair and rumpled sweaters, the idea of genius as something eccentric and approachable. Teachers used his story to inspire, to show that intelligence was not about conforming or memorizing but about asking better questions, seeing connections others missed, having the courage to trust your own mind even when everyone else disagreed. He became a cultural icon, his face appearing on posters and t-shirts, his quotes shared and misattributed, his image invoked whenever someone wanted to represent brilliance or creativity or the power of human thought. But beneath the mythology, beneath the simplified version that popular culture embraced, there was a deeper legacy, one that took longer to understand and appreciate. Albert Einstein had fundamentally altered humanity's relationship with the universe. Before him, space and time were separate, absolute, the fixed stage on which events unfolded. After him, they were dynamic, relative, part of the dance rather than the stage itself. Before him, matter and energy were distinct. After him, they were interchangeable, two forms of the same fundamental substance. Before him, gravity was a mysterious force acting at a distance. After him, it was geometry, the curvature of spacetime caused by mass and energy. He had not just discovered new facts. He had changed the way humans could think about reality. And that change rippled outward, touching fields far beyond physics. Philosophers grappled with the implications of relativity for concepts like simultaneity and causality, for the nature of time itself. Was the past still real? Was the future already determined? If time was relative, if different observers experienced it differently, what did that mean for free will, for memory, for the structure of experience? Artists and writers were inspired by relativity's strangeness, by the idea that reality was not fixed but fluid, dependent on perspective. The early 20th century's explosion of modernism, its breaking of traditional forms and exploration of subjective experience, happened in parallel with Einstein's revolution, and while direct causation is impossible to prove, the cultural and scientific transformations felt connected, both expressions of a world learning to see itself differently. His moral legacy was equally profound, though more contested. Albert had been a pacifist who signed the letter that helped create the atomic bomb. He had been an internationalist who supported the creation of a Jewish state. He had been a refugee who found safety in America but never stopped criticizing its flaws. These contradictions troubled some, who wanted their heroes pure and consistent. But Albert had never claimed to be either. He was a man navigating impossible choices in a world that offered no clear answers. He tried to do what seemed right, even when rightness was uncertain. He spoke against war while recognizing that sometimes violence was necessary to stop greater violence. He supported Israel while warning against the dangers of nationalism. He loved America while demanding it live up to its principles. The contradictions were not failures. They were evidence of someone thinking deeply, refusing easy answers, remaining engaged with a world too complex for simple morality. His advocacy for civil rights left a mark on American history. When the opera singer Marian Anderson was denied lodging at a hotel in Princeton because she was black, Albert invited her to stay in his home. When Paul Robeson, the actor and activist, was persecuted for his political views, Albert defended him publicly. He joined the NAACP, corresponded with W.E.B. Du Bois, spoke out against lynching and segregation. He understood what it meant to be treated as less than human because of identity, and he used his privilege and fame to stand with those who had neither. "I believe in equality before the law and in the universal brotherhood of man," he wrote. And he meant it, not as abstract principle but as lived commitment. The letters kept coming, even after his death. People wrote to him at Princeton, unaware he was gone, asking for advice or sharing ideas or simply wanting to tell him what his work had meant to them. Helen Dukas, his secretary, continued sorting through them, responding when appropriate, maintaining the archive that would eventually become a window into how the world saw Einstein and how he saw the world. Some letters were from scientists, colleagues seeking to honor his memory or continue conversations that death had interrupted. Others were from strangers, people who felt connected to him despite never having met, who saw in his story something that spoke to their own struggles or dreams. There were controversies too, arguments about what he would have thought about developments in physics, about political issues, about Israel and Palestine, about nuclear weapons. Everyone wanted to claim him, to use his authority to support their position. But Albert was not there to clarify, to correct misunderstandings, to explain the nuances of his views. And so he became, in some ways, a mirror, reflecting back what people wanted to see. Pacifists claimed him. Zionists claimed him. Quantum mechanics advocates and critics both invoked his legacy. He had become too large, too symbolic, to be contained by what he had actually said or believed. He had become myth. But the equations remained precise. E equals mc squared did not change based on interpretation. The field equations of general relativity predicted what they predicted, regardless of who invoked Einstein's name. The science was solid, testable, reproducible. And as technology advanced, as telescopes grew more powerful and detectors more sensitive, the predictions kept being confirmed. In 1974, astronomers discovered a binary pulsar system, two neutron stars orbiting each other, and their orbit was decaying exactly as general relativity predicted, energy being lost to gravitational waves. In 1995, the first exoplanet orbiting a Sun-like star was discovered, opening a new field of astronomy that relied on relativistic calculations. In 2015, the Laser Interferometer Gravitational Wave Observatory, LIGO, detected gravitational waves for the first time, ripples from a collision of black holes over 1 billion light-years away, arriving at Earth exactly as Einstein's century-old equations said they would. Each confirmation was a kind of conversation across time, the universe speaking in mathematics, Einstein listening 100 years earlier, writing down what he heard, and future generations checking his work, finding it correct, marveling at how he knew. It was not magic. It was thought, disciplined and fearless, following logic wherever it led, trusting that the universe was comprehensible, that its rules could be discovered, that human minds were capable of grasping truths that seemed impossible. And in that trust, in that refusal to accept mystery as final, Albert Einstein had given humanity one of its greatest gifts. Not just knowledge, but the belief that knowledge was possible. His influence touched individual lives in quiet ways that never made headlines. A child somewhere, struggling in school, told by teachers they were not smart enough, heard Einstein's story and kept trying. A young woman, facing barriers in a field dominated by men, remembered that Einstein had supported equality and persisted. A scientist, stuck on a problem that seemed unsolvable, thought about the patent clerk who rewrote physics and decided to try one more approach. These moments were uncountable, invisible, but they were real. They were part of the legacy too, the ripples spreading outward from a life lived in pursuit of understanding. The Institute for Advanced Study in Princeton, where Albert spent his final decades, became a kind of pilgrimage site for physicists and mathematicians, a place where thinking was valued above all else, where researchers were given time and freedom to pursue ideas without immediate demands for results. It was, in many ways, the embodiment of what Albert believed intellectual work should be. Not driven by commerce or politics or the need to publish constantly, but guided by curiosity, by the desire to understand deeply rather than quickly. Other institutions tried to replicate that model, with varying success, but the ideal remained, a vision of science as something sacred, worthy of protection, essential to human flourishing. And still, the universe expanded. Galaxies drifted apart, carried by the stretching of space itself, exactly as Einstein's equations predicted, even though he initially resisted the idea. Dark energy, the mysterious force accelerating that expansion, was perhaps related to the cosmological constant he had introduced and then abandoned, calling it his greatest blunder. But the blunder might have been right after all, might have been a glimpse of something profound that he could not fully understand without observations that would not come for decades. The universe kept revealing itself, layer by layer, mystery by mystery, and at each layer, Einstein's work remained relevant, guiding, illuminating paths forward. Black holes, which he thought could not exist, turned out to be common, lurking at the centers of galaxies, including our own Milky Way. In 2019, astronomers captured the first image of a black hole's shadow, a ring of light bent around darkness, visual proof of space-time curvature so extreme that reality itself seemed to break. The image was compared to Einstein's equations, and they matched perfectly. A century after he had written them, his mathematics described something no human had ever seen, something that seemed like science fiction but was simply science, strange and beautiful and true. His dream of a unified theory remained unfulfilled, but the search continued. String theory, loop quantum gravity, and other approaches tried to reconcile general relativity with quantum mechanics, to find the deeper structure that connected the largest and smallest scales of existence. None had succeeded yet. The problem was hard, perhaps the hardest problem in physics. But the fact that people kept trying, kept believing that unity was possible, that beneath the apparent complexity there was simplicity waiting to be found, that was Einstein's legacy too. The refusal to give up. The insistence that the universe made sense. The faith that understanding was always worth pursuing, even when the path was long and the destination uncertain. And so the story comes full circle, returning to where it began, to wonder. A boy staring at a compass, mesmerized by invisible forces. A student walking away from what did not serve him, trusting his own path. A clerk in a patent office, filling notebooks with dreams that would reshape reality. An old man in Princeton, still asking questions, still chasing answers, still refusing to believe that mystery was final. Albert Einstein's life was a journey from curiosity to understanding and back to curiosity again, a reminder that the more we learn, the more we realize how much remains unknown. And that is not a failure. That is the glory of it. He never found his unified theory. The equations that would tie everything together, that would show gravity and quantum mechanics as different aspects of the same underlying structure, eluded him. But perhaps that was appropriate. Perhaps the search mattered more than the discovery, the journey more than the destination. Because in searching, in refusing to accept incomplete answers, in insisting that there must be something deeper, Albert Einstein kept the fire burning, kept the tradition alive, passed it forward to generations who would continue the work he could not finish. Science is not a collection of facts. It is a conversation across centuries, each generation building on what came before, asking new questions, finding new answers, discovering that every answer opens more questions. His relationship with God was complex, often misunderstood. He was not religious in any traditional sense, did not believe in a personal God who intervened in human affairs, who answered prayers or demanded worship. But he was not an atheist either, at least not in the way that word is usually understood. He believed in something, though he struggled to name it. Spinoza's God, he sometimes said, a God equivalent to nature, to the laws that govern existence, to the order and beauty that mathematics reveals. When he said, God does not play dice, he was not invoking a deity but expressing his conviction that the universe was fundamentally rational, that beneath apparent randomness there was structure, meaning, coherence. Whether he was right remains one of physics' deepest questions. He wrote once, near the end of his life, about the cosmic religious feeling, the sense of awe that comes from contemplating the universe, from recognizing how vast and ancient and strange it is, how unlikely our existence, how privileged we are to be conscious beings capable of asking why. That feeling, he believed, was the source of all genuine science and art, the motivation that drove people to spend lifetimes pursuing understanding with no guarantee of success or reward. It was the feeling he had lived by, the compass that oriented his entire existence. Not faith in revealed truth, but faith that truth could be revealed, that the universe was knowable, that the effort to know was sacred. His words, scattered through letters and essays and interviews, continued to resonate. Imagination is more important than knowledge. The important thing is not to stop questioning. Try not to become a man of success, but rather try to become a man of value. They were simple statements, easily understood, but they carried weight because they came from someone who had lived them, who had proven through his own life that curiosity and courage and integrity mattered, that you could change the world by thinking differently, by refusing to accept what everyone else accepted, by trusting your own mind even when alone. Young scientists, reading about his life, found permission in his story. Permission to be different. Permission to question. Permission to fail and try again. He had not succeeded at everything. His personal life was complicated and often painful. Some of his later work went nowhere. But he had kept trying, kept thinking, kept believing that the effort was worthwhile. And that persistence, that refusal to give up, was perhaps the most important lesson. Genius was not about being right immediately. It was about being willing to be wrong, to test ideas, to follow logic even when it led somewhere uncomfortable, and to keep going when everyone else said you were wasting your time. The universe he revealed was stranger and more wonderful than anyone had imagined. Time was not absolute but flexible, stretching and compressing depending on gravity and speed. Space was not empty but dynamic, curved by mass, rippling with waves, potentially finite yet unbounded, a four-dimensional fabric that could twist and fold and connect distant points in ways that defied intuition. Matter and energy were interchangeable, different forms of the same underlying substance, meaning that stars burn not fuel but their own existence, converting mass into light, slowly consuming themselves to illuminate the cosmos. And all of it, every galaxy and star and atom, emerged from a beginning, a moment 14 billion years ago when space itself exploded into being, expanding ever since, carrying everything apart, heading toward a future that remained uncertain. None of that was obvious. None of it matched common sense or everyday experience. But it was true, verified by countless observations, woven into the technology that powered modern civilization. And it was beautiful, the kind of beauty that comes from simplicity underlying complexity, from seeing how everything connects, from recognizing that the same laws that govern falling apples also govern colliding galaxies. Einstein had seen that beauty, had described it in mathematics, had shared it with humanity. And humanity, whether it fully understood or not, was changed by the sharing. On quiet nights in Princeton, before his death, Albert would sometimes walk alone, looking up at the stars, thinking about the light traveling across vast distances to reach his eyes, photons that had journeyed for years or centuries or millennia, carrying information about the universe's past, its structure, its evolution. He was connected to those distant stars, made of the same atoms, subject to the same laws, part of the same cosmic story. And for a man who had spent his life feeling like an outsider, who had never quite belonged anywhere, there was comfort in that connection, in knowing that he was not separate from the universe but a part of it, a way the cosmos had become conscious of itself, looking back and trying to understand. That, perhaps, was the deepest truth Albert Einstein discovered. Not relativity or quantum theory or any specific equation, but the recognition that we are the universe examining itself, temporary arrangements of matter and energy that have somehow gained the ability to wonder, to question, to seek understanding. We are stardust contemplating stars, consciousness emerged from chaos, meaning carved from meaninglessness by the simple act of asking why. And in that asking, in that refusal to accept ignorance as final, we become something more than mere matter. We become witnesses. We become participants. We become, for a brief moment in cosmic time, the universe's way of knowing itself. Albert Einstein was one such moment. A particular arrangement of atoms that asked better questions than most, that saw farther and thought deeper, that left behind ideas that continue illuminating the dark. He lived. He thought. He wondered. He contributed something that outlasted his body, his breath, his heartbeat. And now, decades after his death, on nights when you look up at stars bending light around their mass, when you check your phone's GPS calculated with relativistic corrections, when you read about gravitational waves or black holes or the expanding universe, you are encountering his legacy, his gift, his proof that understanding is possible and worth pursuing. The boy who stared at a compass grew into a man who stared at the cosmos. The student who questioned authority became the authority that taught generations to question. The patent clerk who dreamed in equations showed the world that dreams could be tested, proven, built into the foundation of how we navigate reality. And the old man who died with unfinished calculations left behind not just answers but questions, invitations for others to continue the journey, to push further, to see what else might be discovered if only we have the courage to look. So rest now, in the knowledge that wonder remains. The universe is vast and strange and beautiful, filled with mysteries that Einstein solved and mysteries he never touched, mysteries that await the next curious mind brave enough to ask. Close your eyes. Let his story settle into sleep. And tomorrow, when you wake, remember that you too are made of stars, that you too can question, can imagine, can reach beyond what is known toward what might be understood. The compass needle still points north. The light still bends. The cosmos still calls. And somewhere, in the equations that describe it all, Albert Einstein's spirit whispers still. Keep wondering. Keep asking. Keep reaching for the stars. Good night. Dream gently. And let curiosity carry you into morning.